So in this short lesson, we're going to go over two basic computations that you can perform that are commonly used in science explorations. The first is how to compute the average or the mean of a group of data. And the second is how to compute the percent change from one value to another value. Before we get into that, let's go ahead and take a deep breath. And now let's begin. All right, so the first thing I'm going to cover in this lesson is how to compute the average, which is often called the mean, of a group of data. Okay, so first is a definition, and I expect that a lot of you already know this, but just in case, just to be clear, the average, or the mean of a set of data, is essentially just defined to be the sum of all of the data divided by the number of data points that you have. Okay, so if we do a very, very simple example of this, let's say that the daily rainfall of a certain weather station, at a certain weather station, over a 2-week period, which is measured in millimeters, is given below, right? So I've got all of these data points, right? And we might check really quickly. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yay, I said it was going to be a 2-week period. So we can see here that n equals 14. N means the number of data points that we have. Okay. Now, the question is asking us to find the average daily rainfall during this 2-week period. So to do this, what I'm going to do is I'm going to add up all of these values. Okay? I'm going to add up all these values, and then I'm going to divide by the number of data points that we had. Okay? So, I would do 10 plus 7 plus 3 plus 6 plus 1, 0, 0, 1, 0, 9, 15, 7, 2, 4. Yay, I know my numbers. And then we would divide all of this by 14. So I got this to be 65 as the sum, so 65 over 14, which means I got 4.64, right? And if I was going to use this somewhere, I might say something like, the mean rainfall over this 2-week period was 4.64 millimeters. Now, I want you to notice, because part of what we're doing right now is we're talking about scientific writing. You'll notice that when I finish this, I didn't just say, yay, 4.64 circle, or average equals 4.64, I took a moment to write it, and I took a moment to explain it. I said from the calculation above, where I got it from, we can see that the mean rainfall, I defined not just what I found, the mean, but what it was the mean of, the mean rainfall, and I even give more description. The mean rainfall at this weather station over the 2-week period, that all was 4.64. So when we're engaging in mathematical writing or in scientific writing, we're not just doing the math and saying, yay, I did it. Like I survived 4.64, done, right? We're actually taking time to write out sort of a statement of what we found and precisely what it is. Ooh, and I just realized I missed something. I really should have said here minutes ago, we want units here too. Right? People are always asking, like, oh, do I need to show units? Especially in science, definitely. 4.64 millimeters on average is really different from 4.64 meters or feet or inches. So very, very, very important that you include that as well. I'm really embarrassed that I didn't put it there to begin with, but oh well, it is what it is. Now, I do want to point out that there's another way, or maybe a modified way, to compute the mean, especially when we have a large set of data where there are repeated values. Okay? Sometimes we use what's called a frequency chart. Right? Frequency just means how often something happens or how many times something has happened. Right? So let's just look at this example. Suppose that there's a fictional city, Dan Ciego, that doesn't get much rain. Okay? So suppose that in the month of April, there were 15 days where there were 0 millimeters of rainfall. And so what I'm saying here is, rather than in the previous problem where I say the rainfall was 0, 0, 0, 0, 0, 0, 0, 0, 0, I don't want to say it 15 times. I don't want to write out a giant long list of all 30 data points for April. So I'm just going to say, look, there was a rainfall of 0 on 15 days. Okay? And then there were 8 days where the rainfall was 4 millimeters. How would I record that in the chart? Right? Well, I would put my 4 millimeters here, and then I would put my frequency, the number of times that happened, over here. Okay? There were 4 days where there was 6 millimeters, 2 days where there was 9 millimeters, and 1 day where there was 15 millimeters of water. Right? How would you finish filling out this table? And it shouldn't be hard. right? But hopefully you're noticing, oh yeah, well, 6 millimeters, that happened, 6 millimeters, that happened 4 days. And then there were 2 days where it was 9 millimeters. So 2 is the frequency, 9 is the amount. And then we had 15 millimeters on 1 day. Okay. So now the question is, how would I do the mean of this data? Right? The long way to do it would be to say 0 plus 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 0 15 times, plus 4 plus 4 plus 4 plus 4 plus 4 plus 4. Like, I don't want to have to do this 30 times. So here's what I'm going to do. Instead of writing, I'll put it in red because I'm not going to do it. Instead of writing 0 plus 0 plus 0 plus 0 15 times, instead, what I'll do is I'll say, well, wait a minute, I got 0 rainfall 15 times. Like 0 times 15 literally means 0 plus 0 plus 0 plus 0 15 times, right? And then instead of writing 4 plus 4 plus 4 plus dot 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 plus 4, instead of writing all that out 8 times, instead I can just write, well, there was 4 rainfall 8 times, right? Remember that, like, by definition, 4 plus 4 plus 4 plus 4 plus 4 plus 4 8 times is the same as 4 times 8. Like, that's literally what multiplication means, right? So I could continue this, right? 6 millimeters. I should put units here. That would be a good idea. 6 millimeters times 4 days, 4 frequency, plus 9 millimeters times 2 days, and finally plus my 15 millimeters times 1 day. And this is all going to be divided by the number of data points. Now this is really, 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 really important, right? How many data points do I have? Some of you might be inclined to say 5, because there were 5 different amounts of rainfall. But that's not how many days I collected data for. That's not how many data points I have. How many data points I have is the sum of all of these things. If I add all of these numbers up, you should find that there were 30 days. 30, we call them data points. And so that's what's going to go in the denominator down here, right? So when I go to compute this thing, I'd say, well, I had 0 from this one. I had, 0 millimeters from all of those days. I had 32 millimeters from all of these days. I had 24 millimeters from all of these days, 18 millimeters from all 2 of these days, and 15 millimeters from that one day that we got so much rain. Well, like, wow, like almost like a little more than half an inch. And then we add all these things up, right? So if I add these values up, let's see, these 2 give me 50, this is another 39, so that looks like that's 89 millimeters divided by 30. And so when I do this, I've got, let's see here, 2.96 bar millimeters. And remember, just like in the previous one, I'm not just going to stop here and go, yay, I got my answer, done. Like, we're writing about science here, we're writing about math. Let's be descriptive. So if I wanted to include this in a report or an exploration, I would be descriptive about it. I'd say the computation above, that's where I got it from, shows that the average rainfall in Dan Ciego in April, so I'm giving all that data, was 2.967 millimeters. Again, using the appropriate amount of accuracy based on sort of the measurement tools that you have. So I hope that was clear. When you've got frequency charts, it can be a little bit more complicated, but it saves a lot of time to be able to show it this way and express it this way. Now, the second half of this video, I wanted to talk about how to compute percent change. And the reality is, computing percent change is really, really easy. All we really need to do is look at how much the quantity has changed compared with how much it was when we started with it. So to compute percent change, we have this really simple formula. You take your final value, right, the amount that you ended up with, minus the initial value. So this top is basically giving you how much the value changed by, divided by how much we started with. Okay. Now remember, when you use this formula above, remember that you're going to be getting a decimal value. So if you get something like 0.135, that means 13.5%. We do that by multiplying the number by 100 and then using a percent symbol to indicate that we've changed it from a decimal expression into a percentage expression. Okay. So if we did a really simple example of percent change, suppose that the rainfall in January of 2010 in San Diego was 3.38 inches. I looked this up. Right? Then the rainfall in January in 2020 in San Diego was 0.48 inches. Find the percent increase or decrease in rainfall from January 2010 to January 2020. Right? Well, what we found up above, or what we learned up above, is that percent change can be found by taking the final value. Well, in the end, it was 0.48 inches minus the initial value. We started with 3.38 inches, and then we divide by the initial value, 3.38 inches. And what I got here was negative 0.8579, right? So now we need to interpret this, right? Again, you don't just want to say, yay, percent change, I found it, negative 85.8%, I win, right? We want to describe this thing. The words I'm using here aren't magic. You can certainly write it a little bit differently, but we really want to have some of these elements there. The computation above shows that San Diego's rainfall in January 2020 was an 85.8% decrease from the rainfall in January 2010, right? It's a decrease because it was a negative value, right? And then I'm giving the amount of percentage that I found, and I'm giving sort of the starting time and the ending time that I'm working with here. Now, I want to point out, by the way, and this is really important, percent change is always relative to an initial value. And that means that if you reverse the order of the initial and final values, you're going to get a different amount of change. Like another way of thinking about that is, like, for instance, suppose that something is like originally $100, and then somebody says, oh my gosh, like 50% off, right? If it's 50% off, the price goes to $50, right? If then somebody tries to apply a 50% price increase, that doesn't mean that the price goes back up to 100, because now $50 is the initial value of this change. It's only going to go up by half of the 50, so it's going to go up to 75. So it's important to remember, when you decrease something by 30, it's not the same as increasing the other thing by 30%. And I sort of want to show you that. I mean, I showed you this with this little sale example, but I want to show it in this example as well. So suppose that company A increases the use of solar panels from 30 to 60 panels, and company B reduces the number of solar panels they use from 60 to 30 panels. I want to encourage you, pause the video for a moment, find the percent change in solar panels for A, find the percent change in solar panels for B, and then sorry about that, why are these changes different if the number of panels are the same in both scenarios? Okay, so pause the video for a moment, work those out. So for question A, right, the percent change in solar panels for company A, right, would be the final number of panels, 60, minus the initial number of panels, 30. This is sort of like the change in panels, divided by the initial number of panels, 30. This is 30 over 30, which is 1. This means this is a 100% increase in panels. Okay? Then we can go on and look at part B. Right? For B, in this one, the final number of panels was 30, and the initial number was 60. And remember, it's relative to the initial number of panels. So now this is the same change, I mean, the opposite, but it's still a change of 30, but it's relative to the initial amount. This is negative 0.5. That means that this represents a 50% decrease in panels. And the answer for part C, right, why are these changes different? Why are the percent changes different if the number of panels is the same? Remember that the first one was talking about percent change relative to the 30 that they started with. they sort of doubled the amount they had, and they had a 100% increase based on that, whereas the other one was based on the starting value of 60, which means really it's only a 50% decrease because they had started with more of those things. So I hope that distinction makes sense. I just wanted to make sure that it was clear to you why those two values are different. I hope that this all made sense. As always, if you have questions, please let me know. I wish you best of luck as you apply these to your science explorations.